All right, so we want an exponential function that contains these 2 points. So what do we need to do? First of all, we need to remember what an exponential function looks like. So y equals a times b to the x. That's what we're shooting for. Now, your job is to find a and b. Can anybody tell me anything about either one of those?
Is y 9 and then x is 0? Y should equal 9.
Okay, we don't need to do that. Remember, we've talked about this guy right here is always going to be your initial value. It's always going to be your y-intercept. Every time we do that, and Jacob, you absolutely can do that. You can go ahead and plug in 0 for x and 9 for y, but it's going to turn out that a is 9. That happens every single time. So, because some of you have a hard time finishing things on time, I would suggest that you try to be efficient about it. And remember that this is always the initial value. This is always your a value. Now, to find b, you can't do anything like that. You're going to have to do the work for b. So, we'll put in 1/3 and b cubed. Now I need to solve for b. My objective is to figure out what does b equal. So what would I do here to start figuring out what b equals?
Divide by 9.
Yep, divide by 9 is exactly right. I'm going to, instead of dividing by 9, I'm going to multiply by 1/9. Isn't that the same thing? Yes, and it makes it easier with the fraction over here. But dividing by 9, multiplying by 1/9, do whatever you need to do, get rid of that 9. I do want to remind you, the quiz on Monday is no calculator. So whatever arithmetic you do, you're going to have to manage on your own. So we have b cubed equal to 1/27. So now we will cube root both sides, and it turns out that b is what? What is b? Cube root of 1/27.
1/3.
Yep. So that means that don't stop there. That means that my equation is y equals 9 times 1/3 to the x. Please do not ever, under any circumstances, combine these two numbers. They are two separate numbers because the 1/3 has the x and the 9 does not. All right, the next question is, consider another exponential. And describe the end behavior of that curve. Describe the end behavior. Now remember, what that means is you will be writing down, oh, I probably should make that alphabetics. You will be writing down your correct notation for end behavior, which is always the limit as x approaches infinity and the limit as x approaches negative infinity. I would not attempt doing this problem without a sketch. Now, no one's grading your sketch, but if you have a sketch, it gives you a better idea of what your limits are going to be. So we got to think about this in a couple different ways. First of all, this number is less than 1. So this is not a growth function. This is a decay function. Now you can also think about that by flipping this over and making it 3/2 to the negative x. Then you'll have your positive, which would be your normal growth curve, but it's reflected across the y-axis. So you're either going to think about this as decay, or you're going to think of it like this as a reflection. Again, it doesn't matter how you think about it. Process it the way it makes sense to you so that you know this is what it looks like. That's what you have to have. You have to have that visual in your head or written down. Okay? Now, let's describe the end behavior then. You got going to positive infinity, going to negative infinity. So positive infinity's to the right. What is happening to my curve as I go all the way to the right, as far as I can go? What's this limit going to be?
It's getting closer to 0.
Yep, from the top. Yep, that's exactly right. That's exactly right. If you go the other way though, if you go to the left, as far as you can go to the left, what is that curve doing?
Going to infinity.
Yep, going to infinity. So again, you have to use the correct notation, so make sure that you have down that end behavior notation is this right here. And then you can fill those numbers in from your picture. Now, this next one we're going to go ahead and do, but we're going to do some more practice in our notes today. I think we talked about this, but I'm not sure. So let's talk about it now. I got another exponential. Okay? 2 questions. We want the initial value, and we want the rate of growth or decay. All right, so here we go. What's the initial value? We've already talked about this a couple minutes ago when we were building our own equation. Where is the initial value in the function?
It's that A value.
It's the A value, that's right. So it's 137. It's whatever number is right there, that is your initial value. Because if you put a 0 in here, that's going to disappear, and all you're going to have is 137. Now, take a look at that base, that B value. Is this growth or decay?
Decay.
Definitely, because that number is less than 1. So when you keep multiplying, basically you're taking 80.5% of what you had before. So you're going down, 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 down. Now, I kind of gave it away. If I am multiplying by 80.5%, that's what I'm keeping. I'm keeping 80.5%. What is my rate of decay? What am I losing? %19.5%. We talked about this a lot when we did those discount problems. If you're multiplying by 80.5%, then you're losing the other 19.5%. That's gone. So you are decaying 19.5%. Your rate of growth and decay is simply how much more than 1 or how much less than 1 you are. We have a couple of those in our notes coming up today, I think. All right, let's take a look at the last problem. Oh, no, there's 2 more. That was number 3. So we have 2 more to practice. So now we're going to consider a logistic function. Okay, that's a logistic function. And again, 2 questions. We want to know the initial value, and we want to know the maximum value. You know what logistic functions look like. They're trapped in between two asymptotes, horizontal asymptotes, so they have a highest point. All right, how do we find the initial value? Now, in an exponential, it's easy, because in an exponential, you can just look for your A value. It isn't so easy with these guys. What do we have to do to find the initial value? Okay, we're going to let x be 0. We're going to let x be 0. So here I go. I'm putting in 0 for right here. And what's going to happen if I let x be 0? Well, this is going to go to 1. So this will become 6. So it looks like my initial value is 100 over 7. My initial value is 100 over 7. That doesn't reduce, so that's just my answer. Your initial value is always, whether it's exponential or logistic, doesn't matter. It's always what goes here. That's the initial value. Now, the maximum value is also known as the limit to growth. We've talked about this. Someone tell me. I need someone to actually speak and tell me, what have we learned about the limit to growth? The maximum value.
Numerator.
Yep, as long as that's a 1, it's just the numerator. It's actually this over this, but as long as that's a 1, it's just the numerator. So your maximum value is 100. If this were part of a word problem, like if I knew the context of this problem, that would be like 100 people or 100 buffalo or something. But I'll just put 100 because I have no idea what it means. All right, and then the last one, we're going to simplify an exponent expression. And I deliberately tried to trick you on this practice problem. Do not cancel those. What did I just tell you a few minutes ago about combining these two numbers? Can I ever do it? No, not as long as there's an exponent up there. So PEMDAS tells me that the first thing I need to do is take care of the exponent. I am not going to multiply. I am going to take care of the exponent. So what does that exponent do? That negative exponent, what does that do to my fraction?
Flips it.
Yep, thank you so much. Flips it. Now it does not flip the exponent. It only flips the base here. That stays 2/3. Fractional exponents mean radicals. So I have the cube root of 27/8, and I need to square that. So what is the cube root of 27/8?
3/2.
Yep.
0/2.
Cube root of 27, yep, that's right. Cube root of 27 is 3. Cube root of 8 is 2. So now I have 3/2. That's my cube root, but I still need to square it. Don't forget you got a 2 there, so you did the cube root. Now we got to square it. So squaring that fraction will give me 9/4. And now I'm going to multiply, so 27 times 9 is what? Is that 243? So my answer is 243 over 4 if I multiplied correctly. And that is your practice quiz. So your quiz is going to come from that pool of problems. And our quiz is Monday. All right, now we need to get back to our notes. Okay, so I'm looking at my notes, and we are ready to start section 3.2. And this is like this first section, section 1, A and B. These are like on the quiz. So we talked about it a second ago. Now we're going to actually do a couple more. Make sure we got this figured out. All right. So these are both exponentials. This is A and B. They're both exponentials. And we are going to identify them as growth or decay, give the initial value and the percentage of growth and decay. So it's easy to tell if they're growth or decay. You just look at this number right here. Is this problem growth or decay?
Decay.
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 This one is growth, yep. And that's easy to tell because your base here is either going to be bigger than 1 or less than 1, or bigger than 1 or less than 1. And bigger than 1 is growth, less than 1 is decay. Your initial value is always your A value. So for here, it's 5607. For here, it's 3.75. That's easy. You can just look at the problem and tell. Now, the rate of growth or decay is how much different than 1 you are. So this one is 7.2% above 1, or it's 0.072 above 1, which is 7.2%. So this second one is 7.2% growth because we are 0.072 more than 1. The amount that we are either more than 1 or less than 1 is our rate of growth or decay. So this one is less than 1. How much less than 1 is it?
0.037.
Yep. So that would be a 3.7% decay. A 3.7% decay because it is 0.037 less than 1. The amount that you are bigger than 1 or less than 1 is your rate of growth or decay. So that brings us to the next section, or not section, but number 2, which says, write some more exponential functions. Well, shoot, we've been doing this, but we've been doing it using 2-ordered pairs. Now, you're going to write the same kind of equation, but now they're just giving you the initial value and the rate of growth or decay. So for problem A, it says the initial value is 21. Okay, that's easy. And then we are increasing by 21% a year. So our rate of growth is 21%. What does that mean our B number is here? What would that B number be?
1.21.
Yep, 1.21. It's that easy, folks. It is that easy. All right, let's look at B. B says we have an initial value of 0.6, so easy. And now we are decreasing 3% per year. So we're decreasing. So we need to subtract from 1. So our decimal will be what?
0.97.
Indeed, 0.97. That's a 3% decrease. C says the initial value is 6, and it doubles every 3 days. All right, now this is a little bit tricky. Let's leave off the every 3 days part for a minute. And let me just say to you, I'm starting out with 6 tomatoes. And my crop doubles every day. So I'm altering it a bit. I'm doubling every day. Wouldn't I just take 6 and multiply it by 2? And that would be how many tomatoes I would have after the first day. Well, if I went to if I did this for 2 days, wouldn't I just multiply by another 2? So if I am doubling every day, this would be my equation. But I am not doubling every single day. I'm doubling every 3 days. Does anybody have a thought about how we can make this equation accommodate doubling every 3 days?
Would you put 3x?
Actually, you put x over 3. Now, let's talk about that for a second. So you're on the right track. You're on the right track. You just put the number in the wrong spot. In order for my population to double, how many days does it take? 3, right? So if you think about waiting 3 days, if x is the number of days, and you think about waiting 3 days, do you see how that would mean one doubling? I double one time. And if I waited 6 days, I would double 2 times, which is exactly what's happening in the problem. So when we have, I don't know how to say it, some kind of restriction or whatever on the doubling time or quadrupling time, whatever time it is, you're going to divide. You're going to divide by that number to create the opportunity, in this case, to double once in 3 days. You'd have to put a 3 here to make this double. Okay, and then I think there's one more. The initial value is 200, and we're going to be cut in half every 6 years. Okay, it's just like this one, only we're cutting in half. So what are we going to put in here?
1/2.
Either 1/2 or 0.5, whatever you're most comfortable with. If you're cutting in half, it's 50%, so 1/2 or 0.5. Now, if I left my equation like it is, I would be halving every single year. Now, that is not what's happening. I am not halving every single year, so I need to adjust my exponent. What did
X
we
divided by 6.
Exactly, it's x divided by 6. Now, if you wait 6 years, if you put a 6 in for that x, your exponent will be 1, and you'll cut it in half. Every 6 years, you'll cut it in half, your population or whatever it is. Okay, now we're going to need a calculator, so get it out. And we're going to write a couple more exponentials. Using points, just like we are in our quiz. Only the one on the quiz, you won't need a calculator for, but this one you will. And I want to make sure you know how to use your calculator to do it. So we're going to write the equation of the exponential function that contains these 2 points. So keep in mind, this is what you're shooting for. Keep in mind, there's your initial value right there. So we know A is 4. Now, to find B, we're going to just plug in. So 8.05 equals 5B to the x, or B to the, it's 4B to the 5th. There we go. So my A is 4 and my x is 5. Now, how are we going to solve for B? We need to figure out what B equals. How are we going to do that? What is going to be the first thing you're going to do?
Divide
Divide
by
by 4.
Exactly. Very, very good. We're going to be doing a lot of word problems later on, and we've got to remember to get rid of that guy right there. So 8.05 divided by 4, I got 2.0125 equals b to the 5th. Now what do I do?
Take the 5th root.
Beautiful, Liz. Thank you. Take the 5th root of both sides. Now, I'm going to show you, we're going to talk about 2 different ways to do that. I don't know how you've done it in the past, and I don't know what you're most comfortable with. I don't know if you even know how to do it either way. But, obviously, the 5th root of b to the 5th is b. So now, I am either going to physically type in the 5th root of 2.0125. So let's walk through the steps of that, if this is the way you like to do it. The first thing you have to do is tell the unless it's a square root. If it's a square root, you're just going to use your square root button. But if it's some other root, the first thing you have to do is tell the calculator what root you're taking. So I'm going to type 5. Do that first. Type the 5 first. Then go to math. I don't know if you can see where my fat finger is pointing, but your math button. And down the list, for me it's number 5, you see this, or no, you see this key. So you press that key, so go down to number 5, press that key, and then type in your 2.0125 and hit equals. So your B value is about 1.15. Okay, everybody get that? It's pretty easy. The trickiest part is to remember you got to put that 5 in first, whatever your index is. Now, I really never use this button. For me, it's faster to remember that the 5th root of something is just it raised to the 1/5 power. Now, for me, that's an automatic move because I'm a teacher, been doing this for centuries, and I'm very comfortable with exponents. So I recognize that a 5th root is the 1/5 power. So I just take my 2.0125 when I get it on my calculator and raise it to the 1/5 power. And of course, I'll get exactly the same answer. Now, depending on how old your calculator is, when you go to raise this to the 1/5 power, you need to make sure that 1/5 is in parentheses. Some of the newer calculators, that's not a problem because you automatically are typing up high. But for the old calculators, you need to make sure that's in parentheses. Either way, we get 1.15 as our B value. And I can finish my problem by writing my equation, which was our goal. Whoops. So y equals 4 times 1.15 to the x. All right, would you try the next one on your own? It's exactly the same thing, just different numbers, but your goal is the same. You're going to find A and B. put my answer up here. Give me some thumbs up if that's right, or tell me if I've made a mistake. There's some thumbs up.
Supposed to route?
I just did it arbitrarily to the 1,000th.
Okay.
So does that look okay to everybody? Did everybody get 0.839 one way or the other as your B value? All right, good news, very good news. Okay, so now we're going to switch gears a little bit. We're going to number 5 now, and we're going to write logistic functions. Okay, so remember, exponentials are y equals a times b to the x. Now we're going to have a different format because we're doing a different kind of equation. So the format we're going to use for our logistic functions, and there are different formats you can use, but we're going to use the one that we've been working with, which is something over 1 plus something times something to the x. So if you think about, like for example on the practice quiz, the logistic function you had looked like this. So do you see how I'm using this format, but it's exactly the same as what we've been doing? But there's a lot of variables in there. There's a lot of unknowns. So let's look at what they give us in this first logistic problem. It says the initial value is 10. The limit to growth is 40, and it contains the point 120, 1,20. Now, it isn't a coincidence that they had to give me 3 pieces of information because there are 3 variables. And each of those pieces of information is going to help me get one of my variables. I think you know one of your variables already. Can anybody tell me what it is right off the bat?
A equals 10.
A does not equal 10. A equals 40. Isn't that your limit to growth? That's your limit to growth, as long as that's a 1. So you're going to start by putting 40 into your numerator. So that's done. I'm starting right there, getting that taken care of. Now, some of you want to use that 10. Remember, the initial value is really part of a point. What is the point that goes with the initial value? 0, 10. Yep, got to start with a 0. X is 0. The initial value is the value of the function when x is 0. Well, be careful. This should be a 10 then. So 10, y is 10 when x is 0. Now, what happens to this right here?
Becomes a 1.
It does. So now I have 10 equals 40 over 1 plus b. So 10 plus 10b equals 40. 10b equals 30, and b equals 3. So now I know that A is 40 and B is 3. Now, this last point down here is not special. It's a random point that's on the curve. But if I use this x and this y, can you see that I'll just have a c left and I'll be able to solve for it? So here we go. That's going to look like 20 equals 40 over 1 plus 3c to the first. So 20.
Multiply 1 plus 3c to the other side.
Yep. So 20 plus 60c equals 40?
Yeah.
60c equals 20 and c equals 1/3. So I'll plug all that in to my general form there. So A was A was 40, B was 3, and C I just figured out was 1/3. So there's my logistic function. Okay, let's walk through one more together, and then you have one you can work on by yourselves. All right, number 2, I'm going to start with my general form again. So I have A over 1 plus BC to the x. That's what I'm starting with. Look at the information that you've been given. You've been given 3 things. What is the one we know without doing any work?
A is 128.
Yep, your limit to growth is 128. So we're going to just plug that in. And now we can go from here. What piece of information are you going to use next?
The limit value versus 0.16.
Okay, that's the initial value. Yes, the initial value. And so I'll put a 16 in here and a 0 in for x. Remember, the initial value of anything is 0, comma. So we know our x is 0, and they tell us that our y is 16. So we know that b to the 0th is just 1. So basically we have this to solve, because c to the 0th is 1. So 16 plus 16b equals 128. 16b equals 112. And b equals something. Is that 7? Yeah. So b is 7. So now we're almost done. We've figured out that A was 128 and B is 7. So now all we have to do is figure out C. So how will I do that?
Plug in the point.
Uh-huh.
32.
That random point, yep, we're gonna plug that in. So 32 equals 128 over 1 plus 7c to the 5th. So 32 plus, what's 32 times 7? 224. C to the 5th equals 128. I'm going to need a calculator here probably. So 32 times that equals 128. So 224 c to the 5th equals 96. Now I'm going to divide by 224. That reduces down to 3/7. So c to the 5th equals 3/7. Remember to reduce on your calculator. You can just type in 96 divided by 224. When you hit enter, you'll get a decimal. Then just go back to your math menu where we were before. Very first option's frac. Hit enter a couple times and it'll give you the reduced fraction. Now you need to take the 5th root or raise it to the 1/5 power. Whatever works for you. I got a C value of 2.143. Does that match somebody? Okay, thank you. Ollie, where are you? In Florida? Okay, so don't forget to write your final answer. You need your whole equation with all of your values plugged in that you found. Now, we got time to do this last one, letter C, which is at the top of page 3. Everything is exactly the same, except instead of making a list, I drew a picture. So take a second and see if you can find the logistic function that matches this picture. Start with your format so you know what you are trying to find and what it's going to look like when you're done. Let's have a little checkpoint here. Did everybody put 20 in on top? Okay, good. Now I have found B. I don't know if you're there yet or not. Remember, B comes from the initial value because we're going to put 0 in for X. So that's basically going to go away. And that's going to allow me to solve for B. And I got 3. Is that right? Yeah, good. So I'm going to go ahead and put 3 in here. Now I'm going to use my random point and see what happens. Y was 10. I got the square root of 1/3 for my C value, 0.577. Thumbs up, thank you very much, Reed, thank you. Okay, all right, one more quick comment, and we'll talk more about this next week. But on Friday, we have a 25-minute class on Friday, and we will be taking the entire period. All we're going to do that period is take kind of a wrap-up assessment. So it will cover 2.6 through 3.2. We're almost done with 3.2. We have a few more problems to do. And that's what the wrap-up assessment will cover next Friday. I have put in the extra practice folder for chapter 3, I have put 3 worksheets and the accompanying videos to help you prepare for that review. Okay? That one's on your own. We will not be using class time. We do not have class time to do for that. So you will have to take some time on your own. The videos and worksheets are there now for the quiz, quest, assessment, whatever you want to call it, next Friday. Okay? All right. Remember, you're welcome to come and flex at 2 o'clock. Have a great day. I think it's lunchtime.
Thank you.
Mrs.
Bye-bye.
Ford, I
Yes.
have a quick question.
Uh-huh.
So with the calculator on the previous problem, 5B,
Uh-huh.
what was that fraction thing you did on the calculator?
Just go to math. And the very first thing that's highlighted on there is frac. Hit enter a couple times and it will change your decimal into a fraction. That's how you change a decimal into a fraction. So, Jacob, type 0.75. Type 0.75.
Okay.
Hit math, enter, enter.
Okay, alright.
Got it? Okie doke.
Yeah.
Okie doke.